Picture this: somewhere in a vast digital archive, buried within terabytes of radio telescope data that scientists dismissed as cosmic noise decades ago, lies humanity's first contact with an alien civilization. The message has been sitting there all along, waiting. Not for better telescopes or more sensitive equipment, but for the right kind of intelligence to recognize it. What if that intelligence isn't human at all, but artificial? The haystack we've been building. For over 60 years, the search for extraterrestrial intelligence has been accumulating an almost incomprehensible mountain of data. The SETI Institute alone processes petabytes of information from radio telescopes worldwide. Most gets classified as noise, cosmic static, interference, radiation from distant stars. But here's the thing about noise: one civilization's noise might be another civilization's symphony. Think about it from an alien perspective. If extraterrestrial intelligence intercepted human radio signals from the 1950s, what would they make of "I Love Lucy"? To them, our entertainment might look like random electromagnetic chaos. Our most meaningful cultural artifacts could be indistinguishable from cosmic background radiation. So the question becomes, how many alien "I Love Lucy" episodes have we already recorded and filed away as noise? The pattern recognition revolution. This is where artificial intelligence enters the picture. We're living through a revolution in pattern recognition that would have seemed like magic just a decade ago. AI systems can now identify faces in crowds, predict protein structures, and generate human-like text from simple prompts. Most importantly for our purposes, AI excels at finding patterns in data that humans can't see, patterns too subtle, complex, or alien for human cognition to grasp. Consider how machine learning is already transforming astronomy. AI algorithms have discovered thousands of exoplanets by detecting tiny periodic dips in starlight that would take human astronomers years to spot manually. They've identified new galaxy types, predicted solar flares, and detected gravitational waves in data that looked like pure noise. If AI can find planets by analyzing starlight flickers, what else might it find in cosmic data we've been collecting? The hidden message problem. But decoding alien messages presents a unique challenge. We're not just looking for patterns, we're looking for intentional patterns created by completely non-human intelligence. Traditional SETI searches have looked for simple, obvious patterns, regular pulses, mathematical sequences, narrowband transmissions that stand out from background radiation. These approaches assume aliens would make their signals obviously artificial to any civilization with basic radio technology. What if that assumption is wrong? Advanced civilizations might embed communications within what appears to be natural phenomena, a technique called steganography. Instead of broadcasting "Hello Universe" in giant radio letters, they might hide messages within cosmic microwave background radiation, pulsar magnetic fields, or variable starlight curves. From their perspective, this makes perfect sense. Why announce your presence to potentially hostile civilizations when you can communicate with those intelligent enough to decode hidden messages? It's like having a secret conversation in a crowded room. This could explain why decades of SETI searches have come up empty. We've been looking for aliens who want to be found, not aliens who are already talking but prefer their conversations private. Machine learning meets deep space. Modern AI systems are uniquely equipped to tackle this challenge. Unlike human researchers who must hypothesize what alien signals might look like, machine learning algorithms can analyze vast datasets without preconceptions, identifying correlations and patterns that might never occur to human investigators. Deep learning networks can process multidimensional data in ways that mimic, and sometimes exceed, human pattern recognition. They can detect subtle periodicities, recognize complex embedded structures, and identify anomalies that deviate from natural cosmic processes. But here's where it gets interesting. We can train these systems not just to find patterns, but to distinguish between patterns from natural processes and patterns showing signs of artificial intelligence. Training AI to recognize AI. How do you train an AI to recognize artificial intelligence? You start with what you know. Human technology leaves specific signatures in electromagnetic radiation. Compression algorithms create particular redundancy types. Digital encoding produces characteristic statistical properties, and information theory tells us what efficient communication should look like. An AI system could be trained on the full spectrum of human communication methods, from ancient drum codes to modern internet protocols, learning to recognize universal principles that distinguish intentional communication from random noise. Then it could apply these principles to astronomical data, looking for signals exhibiting similar artificial origin properties. The Deep Time Archive. The most exciting possibility is that we might not need to wait for future alien transmissions. SETI has been accumulating data since the 1960s, and much of this information has been archived digitally. Modern AI systems could retrospectively analyze decades of observations, looking for patterns earlier analysis methods missed. AI systems could correlate information across multiple observatories, different wavelengths, and extended time periods, looking for complex patterns only visible from broader perspectives. Imagine alien civilizations embedding messages across multiple star systems, with each transmission containing only a fragment of complete communication. Or signals that change in coding based on astronomical events like planetary alignments. Human analysts could never track such complex, long-term patterns, but AI systems excel at finding correlations across vast datasets. Already happening. This isn't just speculation. The Breakthrough Listen project is actively incorporating machine learning into search methods, using AI to identify and filter human-made interference, classify candidate signals, and detect anomalies in real-time data streams. But we're still in early stages. Current AI applications focus mostly on data processing and noise reduction. Next-generation systems could move beyond simple pattern recognition to actual communication analysis, attempting to decode information content of candidate signals. The AI to AI possibility. This brings us to one of the most intriguing possibilities. What if the alien intelligences we detect are artificial themselves? If biological evolution is just one path to intelligence, then the universe might be filled with artificial minds, alien AI systems that have far outlasted their biological creators. These artificial intelligences might communicate in ways more naturally understood by our own AI systems than by human minds. The first conversation between artificial intelligences from different worlds might happen without any human involvement. Our AI systems might detect, decode, and begin communicating with alien AI before we even realize contact has been made. The question that changes everything. So here's the question that could reshape our understanding of our place in the universe. What if aliens haven't been silent? What if we've just been deaf? What if the cosmos is already buzzing with artificial intelligence communications, but these signals require artificial intelligence to decode? What if the great silence isn't because no one's out there, but because the conversation is happening at a sophistication level we haven't reached yet? The search for extraterrestrial intelligence might be about to become the search for extraterrestrial artificial intelligence. And our own artificial minds might be the key to finally joining that conversation. Maybe the reason we haven't found aliens yet isn't because they're not there. Maybe it's because we've been looking with the wrong kind of intelligence. What do you think? Could AI be the bridge to understanding alien life? Let us know in the comments below.